The question we are solving now belongs to test series 3. It is of signals and systems subject. In specific, it belongs to filter structure realizations. As per the question, the direct form 1 implementation of the LTI system of system function h of z is equal to 1 plus 3z inverse divided by 1 minus 2z inverse plus z power minus 2 is shown in the figure. It has an input of x of n and it contains two parts. One is a variant of delayed version of the input and the other one is the scaled version of the input. The two parts have the gains of 1 and 3. The resultant signal is fed to a summer as shown. Finally, the summer's output is the actual output we want, which is y of n. Please note that here y of n is delayed using two delay elements and the delayed outputs are fed to another summer, which finally feeds to the initial summer that we are talking about. And the gains of each of these paths are given as 2 and a. We need to find the value of a. For finding the value of a, let us assume that there is an intermediate signal W of n. W of n can be written as x of n plus 3 into x of n minus 1. This is due to the reason that W of n is the output of a summer which takes x of n as one input using the part shown, and it also takes the scaled version of x of n minus 1 as shown. Now this signal we got, that is W of n, is fed to another summer to get an output of y of n, where y of n can be written as W of n plus 2 into y of n minus 1 plus a multiplied by y of n minus 2. Now these two equations that we got completely represent the LTI system that we have. On taking the Z transform on both sides, for the first equation we can write that W of z is equal to 1 plus 3z inverse x of z. This is because of the reason that Z transform of x of n minus 1 is z inverse of x of z. Similarly, upon taking the Z transform for the second equation, we get that y of z is equal to W of z plus 2z inverse y of z plus a z inverse a z power minus 2 y of z. So this equation can be simplified as y of z multiplied by 1 minus 2z inverse plus minus a z power minus 2 is equal to W of z. So upon using the two Z equations that we got in Z transform domain, that is 1 and 2, we see that y of z divided by x of z can be written as 1 plus 3z inverse divided by 1 minus 2z inverse minus a z power minus 2. This is actually the Z transform of output divided by Z transform of input, hence this is the system function. Upon comparing the system function that we are given with the system function that we have got, we see that the coefficient of z power minus 2 in the both should be the same. So minus a should be 1, that implies a should be equal to minus 1. Hence the correct option representing the value of a is B.